Okay, hi guys, so we'll be continuing seeing some examples on Eudiometry. Okay, so let's get started. So suppose we have S2G and Cl2G, which on reaction gives 2 moles of HClG. Okay, so suppose we have VML of S2 and VML of Cl2 initially, so they both consume during the course of reaction, and 2 moles of, or rather 2V volume of HCl is produced. So change in volume would be V final minus V initial. In this case would be 0. Okay, let's take another example wherein we have 2 moles of NH3G forming 2 moles of, or rather N2 plus 3 moles of H2. So initially we have 2V or 2 volume of NH3, and which is making V volume of N2 and 3V of H2. So delta V in this case would be V final minus V initial. V final is V plus 3V, which is 4V, minus 2V, which is 2V, is the delta V. Okay, let's take another example. So where we have 2 moles of carbon monoxide reacting with oxygen and forming 2 moles of CO2 gas. Okay, and initially we have 2 volume here, 1 volume here, and finally what we'll be having, this 2 would be exhausted to form 2 moles of, or rather 2 volume of carbon dioxide. So delta V in this case is again V final minus V initial, that would be 2V minus 2V plus 1V, that is minus 1V. Okay, so this is an example of volume contraction. Okay, now let's take another example where we have CH4 gas reacting with 2 moles of oxygen gas to form CO2 gas plus 2 moles of H2L. Okay, so suppose we have 50 volume of CH4, 100 volume of oxygen, both exhausting themselves and finally forming 50 volumes of CO2 plus, and this would be negligible because, as we have already discussed, that volume of liquids and solids would be considered negligible in eudiometry. Okay, so contraction in volume would be 50V minus 50, or rather let's give it a name of delta V. Delta V would be nothing but V final minus V initial. V final is 50V and V initial is 50V plus 100V. So it is a minus V, or we can say that it is a contraction. Okay, contraction of 100V, not 50V. Okay, now let's discuss some of the reactions on hydrocarbons. Okay, so hydrocarbons is CXHY gaseous form reacts with X plus Y by 4 oxygen to form X moles of CO2 plus Y by 2 moles of H2O. Okay, let's suppose it is a 5V, and this 5V would be reacting with X plus Y by 4 moles of oxygen atom to be reacted with 5. This multiplied stoichiometric coefficient of this multiplied by 5 would be the volume used here, and finally we would have 5x formed here, and this would be negligible. Okay, so we can easily see that delta V would be V final is 5x and V initial is 5V plus. So this is not V, this is rather, yeah, this is V only. Okay, so this would be VX. I forgot the V here. Okay, so 5xV rather, no 5xv here and 5v here plus 5v into x plus y by 4. Okay, so we can see that it is a case of contraction in which we have something like this as a delta v. So contraction would be modulus of this, that would be 5v plus 5yv by 4. Okay, so this is the volume contraction in case of burning up of hydrocarbon. Similarly, I'll leave a question for your homework in which you have to identify the contraction for this case. X moles of CO2G plus we have y by 2 moles of H2O. This can be neglected safely. So suppose we have A milliliter. So here you can calculate that we would be using A plus y by 4 minus z by 2 milliliter of oxygen gas, and finally it would be forming XA milliliters of carbon dioxide. So you can calculate the contraction in volume. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing more concepts on eudiometry. Till then, good luck and goodbye.